Hello everyone. So welcome back. So today we will discuss about the problems related to gravitation. Okay. So we will also deal with MCQs and the equation of motion which we have already discussed in our gravitation lecture. Okay. And today we will end gravitation in this lecture only. Okay. So first we will start with MCQs. Okay. First question. The gravitational Write this question in your fair note copy. The gravitational force between two bodies is question A, always repulsive, number B, always attractive, C, either repulsive or attractive, and D, nothing can be saved. So these are the four options. First you try yourself what they have asked. The gravitational force between two bodies is. When in the first lecture of gravitation, I told that gravitational force or the law of gravitation, it says that gravitational force is always attractive, right? That's the reason whenever we throw any object upward, it falls downwards. That is, the gravitational pull of the earth, it is pulling that object towards itself. That is, the force is attractive. So our option B is correct. Okay. Next question. The value of the value of G, that is gravitational constant, is. Options are 6.7 Newton per kg. Option B, 6.7 into 10 to the power minus 11 Newton meter square kg to the power minus 1. Option C, 6.7 into 10 to the power minus 11 Newton meter. And option D is 9.8 Newton meter square kg inverse. See, many students would remember that the value is 6.7 into 10 to the power minus 11. Okay, but two options have got this answer. The change is where? The change is in the unit. Okay, right? So, in case you forget the dimension of G or the unit of G, the SI unit of G, you know that gravitational force F is G m1 m2 by r square. Then from here I can equate G is F, this will be multiplied here, r square m1 m2. Force unit we know is Newton, r is the distance, so meter square, m1 m2, so this is kg and this is kg. So our answer is Newton meter to the meter square kg to the power minus 2, right? This one will be 2. So which answer is matching? Clearly you can see that this is not correct. So option B is correct. Okay. Next question. Question 3. The force of attraction between two masses each of 1 kg kept at a separation of 1 meter is. Option 9.8 Newton, 6.7 Newton, 980 Newton, 6.7 into 10 to the power minus 11 Newton. See what they have asked, the force of attraction, that is we have to use here our Newton's law of gravitation. G value we know 6.7 into 10 to the minus 11 in SI unit, each of mass 1 kg, and separation of 1. So F is basically equals to G. So our answer will be 6.7 into 10 to the power minus 11. That is option D is correct. Okay. Next question. The value of G on Earth's surface is approximately. This value we have calculated in our previous lecture. Okay. Where I have discussed the theory portion. 10 Newton per kg, and you need to remember this value 1000 Newton per kg, C is 0.1 Newton per kg, and D is 100 Newton per kg. So which option is correct? This. G value is approximately 9.8 Newton per kg. So approximately I can say this is equals to 10. Suppose another option is given, option E, but 10 Newton per kg square. Then you have to check the dimension also, that is the unit also, SI unit. So you know what force is equals to mg, right? So G is what? Force by m. Force unit is what? Newton. Meter, and m, that is the mass unit, is kg. So Newton per kg. So this option is correct. Okay. Next, this is our MCQ. We have completed here only. Now we will do one big question which is related to the equation of motion, that is Newton's laws of motion, from there, which I have discussed in my previous lecture. We will use those formulas here. The formula to be used, I am telling this previously only. Formula we are going to use here is this form. Not all this formula will be used, but you have to deal with this only. Okay. Okay. So the question is, a ball is thrown vertically upwards from the top of a building of height 24.5 meter with an initial velocity 19.6 meter per second, taking G equals to 9.8 meter per second square. Calculate the height to which it will rise before reaching before returning before returning to the ground. The velocity with which it will strike the ground, the total time of journey. So this we need to find. So see first what they have given. They have given a ball is thrown vertically upwards from the top of a building of a height with an initial velocity 19.6 meter per second. That means u is given 19.6 meter per second. Height, that is h, or I can say by s also, whatever you can use, 24.5 meter. G they have given 9.8 meter per second square. You have to calculate the height to which it will rise before returning to the ground. So this is, suppose, my ground, and a ball is thrown vertically upwards. Okay, this is the height it has achieved, that is height h, from the top of a building of a height 24.5 meter. I am using h only. Okay, the height to which it will rise before returning to the ground. So this is the height of the top of a building. This is the height of a top of a building, this h. This is, suppose this is the building, but I need to find the height where the ball will reach at its maximum. That is the maximum height the ball can reach. Okay, so we will use this formula here. When the ball will reach the maximum height for that millisecond, or I will say a very fraction of second, the velocity will be zero. That is, the final velocity will be what? Zero. Initial velocity is already given, 19.6 meter per second, and since the ball is thrown vertically upwards, so g will be what? Minus of g, because basically we know the direction of g is always downwards, but when the ball is thrown vertically upwards, we will take a negative sign. Okay, so I will use the equation v square equals to u square plus 2 minus gs, that is u square minus 2gs. So this is 0, u square minus 2gs, or u square equals to 2gs. You need to find s from here. This is s, this is s. So I'm getting s is equals to u square by 2g. U is what? 19.6 into 19.6 by 2 into 9.8. 9.8 into 2 is 19.6. This 2 will cancel out. So I'm getting 19.6 meter. This is my s. Okay, the maximum height the ball has attained. Second question is what? The velocity with which it will strike the ground. Okay, so the velocity at the when the ball is returning from the highest point, at that point my u is 0. At the highest point when the ball is returning, at that point my u is 0. Okay, so and the total height traveled by the ball, total height traveled by the ball is what? 19.6 plus the height of the building, that is 24.5 meter. So you can see, if you calculate this, you will get it 44.1 meter. Okay, now if v is the final velocity, then using the equation of motion which we have already used before, we will get v square is equals to what? U square plus 2gs, but this time g is positive. Why? Because the ball is thrown downwards. Okay, so u is 0 plus 2gs. So my v is equals to root of 2gs. So 2 into 9.8 into 44.1. If you calculate this, I hope calculation part you can do. If you have any problem, then please let me know. In calculation part, if you have any problem, let me know. Okay. The answer you will get is 29.4 meter per second. Third question, the height, the total time of the journey. Okay, the total time of the journey, first the ball is thrown upwards and then the ball is thrown downwards. So this is time t1 and this is time t2. Okay, so in this case my g is negative, and in this case my g is what? Positive. So for first case, that is case 1, t1. Okay, when we are finding t1, we will use the equation of motion v is equals to u plus of minus of g t, right? V is 0, u is 19.6 minus 9.8 t1. So from here I am getting t1 is equals to 19.6 by 9.8, that is 2 seconds. Okay, now in the second case my u is 0 and g is positive. So v is 29.4, which we have calculated in my second part. See, this is 29.4. So 29.4, u is 0 plus g t2. So t2 is equals to 29.4 by 9.8. So this is, if we calculate, you will get 3. So 3 seconds. So total time is equals to 2 seconds plus 3 seconds. So this is equals to 5 seconds. Okay, so this is our total time. So this was a big question. I opted this questions because small part is there in the question, and maybe just in the question they have asked you only the first part or the second part or the third part. Okay, so today we'll stop here only. Thank you so much. Keep studying.